At exactly 2:17 p.m. in the Gulf of Oman, 68 Iranian sailors inside a Russian-built submarine made a decision that would become a case study in why obsolete weapons remain dangerous. The IRIS Tareq, one of Iran's 3 operational Kilo-class diesel-electric submarines, had been stalking the USS Nimitz carrier strike group for 41 hours. Through a periscope designed during the Reagan administration, the captain watched the carrier's wake churn white trails across blue water. Range, 11,200 meters. Bearing steady. Speed constant. The mathematics looked perfect. They weren't. The Nimitz wasn't alone. 87 nautical miles to the southwest, a Virginia-class attack submarine designated USS Mississippi had been tracking the Tareq since it departed Bandar Abbas 6 days earlier. Every valve noise, every propeller revolution, every time the diesel engines charged the batteries. The Americans knew the Iranian submarine's exact position before its own navigator had finished plotting the course. The concept of surprise existed only inside the Tareq's hull. Submarine warfare follows brutal physics. You can't kill what you can't reach. You can't reach what's watching you from angles you'll never see. The Iranians were operating a 1992 submarine using 1970s Soviet torpedoes against a carrier protected by surveillance networks that treat the ocean like a 3-dimensional chessboard. The technological gap wasn't measured in years. It was measured in generations. The Kilo-class submarine represents decent Cold War engineering trapped in a maintenance nightmare. Iran bought 3 of these boats from Russia between 1992 and 1996 for roughly $600 million each. 74 meters long, 2,325 tons surface displacement, diesel-electric propulsion. The design trades speed and endurance for stealth. Maximum submerged speed tops out around 17 knots. Operational depth caps at 240 meters. The hull is coated with anechoic tiles designed to absorb enemy sonar pings, but Iran struggles to maintain them in the Persian Gulf's warm, corrosive water. Large sections have deteriorated, creating acoustic signatures that make the boats easier to detect than their Soviet designers intended. The Tareq's crew operated under layers of self-deception. They believed their approach had been undetected because American surface ships hadn't altered course. They interpreted silence as invisibility. They didn't understand that modern anti-submarine warfare operates on different principles. You don't reveal detection until you need to act. You track, you catalog, you wait. Inside the Tareq's cramped weapons compartment, Torpedo Tube 1 flooded with seawater. The weapon loaded into the tube was a test, 71 MKE, the export variant of Russia's wire-guided heavyweight torpedo. This is 1981 technology packaged for nations who can't afford modern alternatives. The torpedo weighs 1,820 kilograms with a 205-kilogram high-explosive warhead. It travels at 40 knots using silver-zinc batteries and wire guidance from the submarine. Maximum range, approximately 20 kilometers at slow speed. The test. 7-1's guidance system relies on commands transmitted through a copper wire that spools out behind the torpedo like fishing line. The submarine's fire control computer sends steering corrections down the wire, aiming the weapon toward the target. When the torpedo gets close enough, it cuts the wire and activates its own active sonar to home in for the kill. In theory, this gives the firing submarine control throughout most of the attack. In practice, the wire snaps if the submarine maneuvers too aggressively or if the torpedo encounters thermal layers. The 1970s designers never anticipated. The Tareq's crew had never fired a live test 71 inches combat. Their last training exercise with practice torpedoes happened in 2019. 2:22 p.m. The order came down in Farsi. Tube 1, fire. Compressed air expelled the test. 7-1 from its tube. The weapon's motor ignited. Wire began spooling from both the torpedo and the submarine. The Iranian fire control team fed steering commands through the copper connection, guiding their fish toward the carrier's massive heat signature 11 kilometers away. The American response wasn't immediate. It was pre-positioned. 90 seconds before the Iranian torpedo launched, the USS Halsey, an Arleigh Burke-class destroyer positioned 14 nautical miles from the Nimitz, deployed an MH-60R Seahawk helicopter. This wasn't reaction. This was choreography. The destroyer's AN/SQS-53C bow-mounted sonar had detected the Tareq's torpedo tube flooding sequence. The sound propagated through water at 1,500 meters per second. The Halsey's sonar operators tagged the acoustic signature within 7 seconds. The MH-60R carries sensors that turn helicopters into flying anti-submarine warfare platforms. Its AN/AQS-22 dipping sonar deploys a transducer on a cable that can listen at depths up to 460 meters. The helicopter also carries sonobuoys, disposable listening devices that parachute into the water and transmit acoustic data back to the aircraft. Each sonobuoy costs roughly $1,400. The MH-60R can carry dozens. The helicopter's mission system processes acoustic data in real time, sharing target information with surface ships and submarines through encrypted data links. Within 180 seconds of the torpedo launch, the helicopter had dropped 8 sonobuoys in a grid pattern between the Tareq and the Nimitz. These sensors created an acoustic fence. The test, 7-1, had to pass through monitored water to reach its target. The Americans weren't guessing where the torpedo was. They were watching it swim. The carrier's defensive posture shifted from routine to active. The AN/SLQ-25 Nixie-towed torpedo decoy deployed from the stern. This is a noise-making device towed behind the ship on a cable roughly 2,000 feet long. It generates sounds designed to mimic a ship's acoustic signature, luring acoustic homing torpedoes away from the actual hull. The Nixie works against torpedoes that listen for propeller noise and engine sounds. The test. 7-1 doesn't care about acoustic signatures. It's wire-guided until the final moments. It follows commands from a human operator staring at a fire control display, not automated sensors that can be fooled by decoys. This is the problem with wake-homing and wire-guided Soviet torpedoes that defense analysts have worried about since the Cold War. Traditional countermeasures don't work. You can't decoy a weapon that's being steered by a person watching your actual position, but you can kill the guidance. The USS Mississippi represents a different category of naval weapon entirely. Virginia-class attack submarines are built around the philosophy that stealth enables lethality. At 377 feet long, with a submerged displacement of 7,835 tons, the Mississippi is larger than the Tareq but infinitely quieter. Its pump-jet propulsor eliminates the cavitation noise that conventional propellers create. Its hull coating absorbs sonar returns. Its S-9G nuclear reactor generates 40,000 shaft horsepower without requiring the Mississippi to surface and run noisy diesel engines to recharge batteries. The BQQ-10 sonar suite processes acoustic data through algorithms that can distinguish a shrimp colony from a submarine at 40 nautical miles. The Mississippi, still tracking from depth, didn't fire torpedoes. It activated something quieter and far more devastating. Its BQQ-10 sonar array lit up with a single active ping. One pulse of sound, transmitted at maximum power, directly at the Tareq. The acoustic shockwave hit the Iranian submarine like a physical blow. Inside the Tareq, the sonar ping was loud enough to rattle equipment and temporarily deafen anyone not wearing ear protection. More importantly, it told the Iranian captain exactly what he'd feared but hadn't confirmed. An American attack submarine was behind him, close enough to hear his heartbeat, close enough that its Mark 48 ADCAP torpedoes could hit his engine room in under 90 seconds. The Mark 48 ADCAP represents what happens when you spend decades perfecting a single weapon. These torpedoes weigh 3,500 pounds with a 650-pound high-explosive warhead. They travel at speeds exceeding 55 knots using Otto Fuel 2 monopropellant. Maximum range exceeds 50 kilometers. The guidance system uses fiber optic wire that doesn't snap like copper. active and passive sonar that can discriminate targets in cluttered environments, and artificial intelligence that allows autonomous search patterns if the wire is cut. The Mark 48 is designed to detonate under a ship's keel, creating a bubble that breaks the vessel's spine. The Iranian captain faced a choice with no good options: continue the attack and die, or cut the wire and surface. He cut the wire. The test, 7-1 Torpedo, suddenly blind, began its terminal search pattern. Its active sonar activated, pinging frantically for a target signature. The weapon circled, searching for the massive hull it had been aimed toward. The problem was physics. The torpedo seeker, designed in 1981, couldn't distinguish the Nimitz's complex thermal wake from the Gulf of Oman's layered water temperatures. After 6 minutes of searching, the torpedo's battery began to fail. Its motor slowed. Its computer recognized it had missed. Then it detonated. The explosion occurred 340 meters from the Nimitz's starboard quarter. The blast created a pressure wave that radiated outward through the water, not close enough to crack the keel or breach the hull. Close enough to rattle the ship and send shockwaves through compartments. Sailors felt the deck shudder. Alarms sounded in damage control stations. But the carrier's double hull absorbed the shock without structural compromise. The explosion's energy dissipated into the ocean instead of tearing through steel. Damage assessment took 14 minutes. Minor flooding in one ballast tank, hull integrity maintained. Propulsion systems operational. Flight deck status, green. The Nimitz continued on course without reducing speed. The Tareq surfaced 4 minutes after the blast. 68 Iranian sailors climbed onto a rust-streaked deck and stared at empty horizon. No American ships visible. No aircraft overhead. Just the humiliation of knowing they'd been tracked the entire time, allowed to launch, and then checkmated without a shot fired in their direction. The USS Mississippi shadowed the Iranian submarine back to Bandar Abbas. Every acoustic signature recorded, every maneuver cataloged, every weakness documented. The Virginia-class submarine never revealed its exact position or fired a weapon. It didn't need to. But the story wasn't finished. 43 hours later, another Iranian Kilo-class submarine experienced catastrophic flooding during training exercises in the Mediterranean. The official Iranian statement blamed mechanical failure. Western intelligence analysts noted the timing. The Mississippi had transmitted detailed targeting data on all 3 Iranian Kilo-class boats to 5th Fleet Command immediately after the Gulf incident. The message was clear. We know where all your submarines are. We can reach them whenever we choose. The cost analysis writes itself in numbers that explain strategic humiliation. Iran expended one test, 7-1 MKE Torpedo, with a replacement cost of approximately $500,000. Operational deployment costs, including fuel, crew, and support, totaled roughly $2.7 million for the 6-day patrol. The submarine's crew will require psychological counseling after experiencing the acoustic shock of an American active sonar ping at close range. Training for future deployments must now account for the fact that Iranian submarine movements are transparent to American surveillance. The political cost of demonstrating that their submarine force poses zero credible threat to American carrier operations, incalculable. The United States expended one active sonar ping. Electrical cost, negligible. 8 sonobuoys at $1,400 each, totaling $11,200. Helicopter flight operations. Standard carrier group budget. Total American expenditure for neutralizing the attack, under $15,000 in consumables. 0 weapons fired, 0 casualties. 0 structural damage to the carrier. Return on investment. Complete elimination of Iranian confidence in submarine operations against American carrier groups. The real calculation isn't financial. It's strategic deterrence measured in acoustic fingerprints. Every sound the Tareq made during its 6-day patrol was recorded and analyzed. Iranian submarine doctrine is now documented in American targeting databases. Future encounters won't require active sonar pings. The next Iranian captain who attempts this mission will surface to find Mark 48 ADCAP torpedoes already positioned in his escape routes, fired from submarines he never detected. This is modern naval warfare stripped of mythology. It's not dramatic surface battles with visible explosions. It's surveillance networks that detect threats before they deploy. It's acoustic sensors that track submarines across entire ocean basins. It's torpedoes that can loiter for hours, waiting for targets to swim into pre-calculated kill zones. The Iranians brought a 1970s weapon system to a fight dominated by technologies that treat the ocean like transparent glass. The Nimitz carrier strike group continued its patrol. Scheduled flight operations resumed 22 minutes after the explosion. The incident was logged, reported, and classified. For the carrier's crew of 4,500, it was Tuesday afternoon. For Iran's naval command, it was proof that their submarine force operates under the permanent gaze of American surveillance. Every deployment tracked, every maneuver cataloged, every weakness exploited. The mathematics of deterrence don't require explosions. They require certainty. The certainty that attempting an attack guarantees detection, neutralization, and the permanent loss of operational secrecy. Iran's Kilo-class submarines aren't invisible hunters prowling dark water. They're tagged specimens swimming in a monitored aquarium, alive only because the apex predators choose to observe rather than eliminate. The Tareq returned to port with a crew that understood they'd survived through American restraint, not Iranian capability. That knowledge corrodes operational confidence more effectively than any torpedo ever could. You can replace damaged ships. You can't replace the belief that surprise remains possible when the enemy proves it sees everything. If you found this breakdown valuable, subscribe and share this video. Your support brings more untold stories of modern military operations to light.